Hi, everybody. I wanted to talk a little bit about what we were doing in class today and kind of hit that final point again about how we can take these two seemingly different equations and think about them in terms of what we did on Friday. So this equation in blue is about how we calculate an increase in pH by adding a strong base within the buffer range. So we're starting with some amount of conjugate base and weak acid. We add some strong base. That strong base will react away some of the weak acid and convert it to conjugate base, increasing the pH. On our titration curve, what that would look like is starting someplace where we've got some moles of conjugate base and weak acid. And then as we add that strong base, the pH increases. In class today, we were particularly calculating that increase up to the area where the buffer range stops. But we could actually calculate an increase anywhere in the buffer range, including to that place where it stops. The red equation is what we were doing on the board towards the end, where we were looking at how we decrease the pH by adding a strong acid. Again, we're starting someplace in the titration curve where we've got some amount of conjugate base and weak acid present. Adding that strong acid reacts away the conjugate base and produces additional weak acid. So this has the stoichiometry of the strong-weak reaction built into the Henderson-Hasselbalch equation. And again, on the titration curve, this could be starting at any point, but we will take it as if we're starting with the same amount of conjugate base and weak acid. And then adding that strong acid would decrease our pH to any point in the titration curve. Again, today in class we were looking particularly at getting at that starting area of the buffer range. Both of these, though, by thinking about it in terms of weak acid and conjugate base, can actually be thought of as going from the very beginning of the titration curve to any of those points. The relationship between the weak acid and the conjugate base is such that we can convert between the two by adding strong acid or a strong base. So when we look at this X position, we can actually think about getting to that particular spot with some amount of weak acid and conjugate base present by starting as if it was all weak acid and then going to that point. We can calculate that just like we did on Friday. Instead of using those other equations, using this green one, the one we used on Friday, we're looking at the total amount of buffer, the conjugate base moles plus the weak acid moles. At this green point, it would be all weak acid. But we can imagine any point along this green line being some amount of conjugate base and weak acid. So we can get to any one of those starting conditions. We can then also imagine calculating to that red line, calculating to the beginning of the buffer range, or calculating all the way to this blue line. We can, using that one green equation, calculate any of these points. And the reason I like using the green equation is because I don't need to think about adding strong acid or strong base to create my proper ratio of conjugate base to weak acid. I can think about it at the beginning of the titration curve and then just the amount of strong base, the amount of strong titrant needed to get to any one of those points. It simplifies the conceptualization a little bit. However, we do have to be aware of the fact that some problems specifically ask for us to do from one point to another point. In those situations, through careful dissection of the concepts and chemical understanding, we can, again, in almost every condition, go back to using that green equation in terms of at the start, where it was as if it was all weak acid, how do I get to a certain amount of weak acid and conjugate base? Because ultimately, through the buffer range, all that matters is that ratio of conjugate base to weak acid. How we get there can be multiple different directions. And since we have multiple different directions that are all essentially equivalent to each other, this one green equation becomes the easier one to use.